Kia ora koutou and welcome to the Internet of Awesome Things podcast, brought to you by Spark. I'm Russell Brown. If you've been with us for the long haul, since episode 1, you might recall that the original IoT devices were connected by wires. Solid, sensible, inflexible wires. That all started to change as far back as the 1990s, when technologies developed for mobile phones turned out to be more effective and cheaper in the long run than wired networks. And in 2019, when we talk about the Internet of Things, we are basically talking about a wireless internet. And with the latest generation of wireless technology in the wings, 5G, things are about to get really interesting. But there's a road to travel yet to ubiquitous 5G, and the wireless Internet of Things will continue to expand and diversify before we get there. With me now to talk about all that are Spark's lead for network evolution, Colin Brown, and telecommunications commentator Paul Brislen. Welcome, gentlemen.
Thank
you.
You.
Now, Colin, we're going to talk about 5G, obviously, but maybe we should start with how we got to 5G. The story of wireless networking is basically the story of the mobile phone, isn't it?
Yeah, look, the G in the 5G stands for generation. So the best way to probably visualise this is to think about every sort of 5-10 years or so, there's actually an evolution of a significant change in terms of mobile technology that actually is a generational shift in terms of the way we use things. So if you think back to the original first generation of mobile phones and even car phones in those days, it was all about having a voice communication service. And that's how cellular phones effectively started to come into being. The next wave of generation brought things like texting, so SMS texting, so the second generation of mobile technology, brought a new service which enabled people to do that. New Zealand was actually probably one of the highest texting nations in the world, predominantly, I think, at the time because of our calling rates. Third generation came along and everybody was walking around with the BlackBerries. And that basically gave you email access, so sort of a lowish speed sort of internet access to your phone, so people could actually start to bring more business applications. In particular, email was a very significant one. 4G came along and that brought higher bandwidth and higher data speeds, and so then that unleashed the things like social media, video, and if you think about the opportunity for now to actually not just actually have it as a mobile technology, but as an alternative to fixed access. And so this concept of fixed wireless access came to play. So, and you see effectively the big thing that actually really changed with 4G was the extent of video now being carried on mobile networks, which 80% of traffic on any sort of network at the moment is probably video. And that's YouTube, that's then Netflix came along. Facebook and the likes that came along in that. The fifth generation of mobile technology then brings effectively the next evolution, and it brings together three discrete things. One is the ability to actually just supercharge that bandwidth. So you're going sort of like, from megabits to gigabits per second on your mobile device. Or on your wireless broadband. You've got a super high latency, or low latency, where the ability to push the trigger on a button and have the network respond to that in a really fast reaction time. It's what we call low latency. And the third thing that you've got is the ability to bring millions of devices and the massive machine-to-machine type communication, and that's the IoT aspect of 5G. And the real sweet spot you get all that coming together is how you bring the sum of all those parts together to actually bring capability to life, and capability that we haven't probably really imagined yet, similar to we didn't really imagine the extent that Netflix would change our viewing patterns on 4G. 5G is really bringing, I guess, that opportunity to actually bridge that. And it's also very much an industry or an IoT play, because, if you look at the latest Ericsson mobility report, for example, where mobile phone penetration around the world is now at 104%. So there's more phones than there are people in the world. So the next real thing is about how do we get things talking to each other, and I think that's where the big part of IoT and 5G comes to play.
Paul, you were working in the industry through 3G and 4G, and there was a step change. Do you think what's coming will be bigger than those?
Oh, I think so, yeah. Certainly in terms of, as Colin says, in the business realm, because 3G and 4G really brought the mass consumers on board. We sort of moved it from a business device to a consumer device. This moves us on again into this machine-to-machine Internet of Things device market, where anything that needs to be connected up, that needs diagnostic analysis or needs to report back to base or anything along those lines will be able to be connected. And that broadens out the range of devices hugely from something that you or I would carry around in our pockets to the pockets themselves, everything around us, anything that's got a plug on it, basically, you could consider putting on 5G. And that's going to be very interesting and very open up a lot of opportunities, I think, for a lot of new business models and a new way of looking at things.
And yet, on the other hand, most of the installed base out there at the moment of IoT devices is on LoRa. Well, certainly through the Spark network, which is a low bandwidth, low battery drain technology. Will that continue to be the case for quite a while yet?
Yeah, look, I think you'll see, with 5G, we still, the standards for 5G have been broken up into two main components. So the first release of 5G was all about that super low latency and high speeds. And the next release of 5G, release 16, is bringing in the IoT elements of that. So 4G and LoRa, and just to distinct between the two, one is effectively using the current sort of 3GPP standards for communication, and LoRa is a separate technology using different ways of communicating to the devices to actually enable that to happen. And what you're going to see with IoT is a horses for courses type approach. So LoRa is very good. It stands for long range. It uses very long battery life and very efficient ways to actually get spectrum efficiencies and relays to actually get the devices out as far as possible. With 4G and IoT, you're starting to see the rise of higher bandwidth demands. Like, for example, in the machine-based standards for 4G called CAD-M1, for example, it's about 1 megabit per second. You can even carry a VoLTE service over that. NB-IoT will start to come into play. So it really depends on what service you want, what you're trying to deliver for that against the technology that you'd have. So LoRa will have a place, NB-IoT will have a place, CAD-M1 will have a place, and so will some of the sort of effectively the 2G networks that do some of the IoT aspects, which some of the other carriers have still got in place will still continue. So really it depends on what you need.
But I guess that's a key and significant thing there is that 5G and already 4G has the benefit of these IoT-specific standards. So machine to machine is it's assumed that this will be a key part of the picture.
Yeah, and look, and I think that's the big difference is when you're actually operating on a sort of effectively a managed network, the carrier has the responsibility for making sure all of the services are all working end to end, and you're actually you do a lot of your spectrum planning and your radio planning in and around what you expect in terms of the capacity demanded and around that. And I think that's the big aspect around using the 3GPP standards for NB-IoT and CAD-M1 going forward is going to be a big part of. Yeah.
Now, before we talk further about 5G, Paul, I'm going to ask you to answer the question. I see people who are alarmed on Facebook. Please tell me that 5G isn't going to melt my eyeballs and kill my cat.
No, I'm fairly sure your cat's safe, and I think your eyeballs probably as well. Look, there is a lot of concern around this seemingly new technology that's coming out of nowhere, and oh my gosh, the health implications haven't been thoroughly thought through. As Colin said, this is a generational thing. It's not come out of nowhere. It's well established. I think by now, with the number of devices we've got around the world running electromagnetic frequencies, you would have, if there was a problem, we would have seen it by now. Health records right throughout the world show that the number of instances of brain tumours, of brain cancers, of anything that might be associated with cell phone use or mobile device use have remained flat for the last 100 years. They haven't gone up, they haven't gone down, they've varied very little. And I think by now we would have seen some evidence if there was anything to be found.
You're much more polite when you're on mic.
I do try. But I mean, look, it's a valid concern. People haven't been told how this stuff works in any way they can really grasp. Facebook is very good at amplifying fears and sharing them, and you can always find a group of people who are concerned. I did a little bit of research on Facebook. I try to avoid it at all costs, but I went on Facebook this morning, typed in 5G, and the first page of results within Facebook were all about groups opposing it, health concerns, the secret is out, the truth isn't being told, all this kind of stuff. And there isn't a single positive, factual story amongst them. And a lot of people these days get their news from Facebook, which is a real concern.
Sounds like someone should actually provide such a resource.
You would think so. And I do think an official, Collins from the industry, of course he'll say these things are all fine. And I used to work there. Of course he's biased one way or another. You need officials coming out saying, look, this is actually, it's tried and tested. We're all good. Let's move on. And I think there's a mass of people out there who will say, okay, fair enough. Let's just get on with our lives. You're not going to convince the people at the extreme ends. That's fine. They can carry on feeling upset about this, but it shouldn't hold up the rest of us.
Right. Well, now we've got that out of the way. Colin, what is the roadmap? How does Spark expect to proceed?
Look, we're in current trials at the moment, and we have a lab down in the Wynyard Quarter. That's being used to demonstrate both the radio access technology together with how it's going to work with the new core. So radio, if you think about mobile networks, they have the radio antenna and the ability to actually radiate and receive signals. And then back in the brains, you have this aspect called what we call the mobile core. So what we're at the moment doing is integrating a range of our technical radio access technology partners into the core and seeing how the different vendors play out. And then we're also using that as an opportunity to showcase what we think 5G could actually enable and release as potential for New Zealanders. So a big part of that is actually just demonstrating a range of use cases. We've got drones, we've got IoT down there, we've got demonstrations of what latency can actually do. The first 8K TV in New Zealand was actually installed down there. So there's a whole bunch of things that we're doing down there, VR, AR. And that's one aspect around it. And the other aspect is then once we can showcase that, then how do we bring our customers in to co-create with that technology to then understand how this new technology could potentially overcome the barriers of entry of advancement in their technical solutions going forward. And the best case I've got around that is probably the work that we're doing with Paymark, who introduced FPOS machines 30 years ago into New Zealand. They're experimenting with facial recognition, so and for micropayments. So how could you walk into a store, see something in terms of your retina, in terms of understanding that, tie that to a bank account code, and then be able to walk into the store, micropayments, get your coffee and walk out without having to do a payment. The big barrier for them in the past has been the physical wired infrastructure required to actually establish, installing the cameras, connecting that back to an AI and a machine to actually make sure it does all of the processing and then respond to that as fast as possible to then recognise the person, the bank account, and allow that transaction to happen in a seamless way. And that's what I mean about the sum of all the parts. It's bandwidth, it's latency, it's masses of machines connected to each other to actually pick up that capability. We've done a lot of work with Omeo to look about how we can actually do some connected cars.
Yeah, Omeo are the driverless car.
Driverless car. Now, just to clarify, 5G is not the driverless aspect of that. It's just one of the connectivity layers. They use this thing called light radar, and they also use GPS, so it's not the sole control there, but it provides an element of actually connecting the car, communication with the car, monitoring the various things in the car, as well as providing another layer of resiliency around where it's actually tracking around its path. And they're actually, I think, down in Christchurch at the moment, the airport, starting to deploy autonomous vehicles down there, and that's an exciting opportunity. We'd love to work more with them on there. So we just sort of see we're very much on the painting, providing the canvas for people to paint what the opportunity will be. And we're pretty realistic about where it will play out. Fixed wireless access for 5G will continue to be a big, strong driver for us. It's a compelling use case to deal with the capacity we have on the network. But we also see there's a real good opportunity to actually work with businesses in New Zealand to sort of say, how does this unleash your potential? Because actually we're network builders, we're not necessarily the people using the end application, and we'd love to sort of find out more about that.
Paul, you've had a look at the potential applications, 5G-enabled applications, IoT applications in vehicles. It goes beyond just the idea of the autonomous car, doesn't it? There's quite a wide spread of use cases.
Oh, absolutely. And it's that low latency that 5G brings, that ability to press a button and have the network computer respond immediately, that is really critical. So I'm thinking about things like Google recently bought Waze, which is an online real-time traffic monitoring tool. So anybody in the future, of course, anybody sitting in the car with a 5G-enabled device, the network of users will be able to report back to each other on where the congestion is. So you'll be sitting in the car, real-time traffic updates as they come in. Don't know what's happened, but all the cars seem to have stopped up ahead of you. Try going down this side street and we'll work our way around that way. That kind of thing is immediately obvious and immediately available. But there are so many other opportunities. It's mind-boggling. And the good news is smarter people than us are thinking, hang on, this is exactly what I need for that project around aging population and health, or any manner of other elements that need that instantaneous real-time reporting capability.
I think one interesting thing about that, things like traffic congestion, there's an interface there between the public and private sectors, which is something I actually see in IoT quite often, because that data is of public value as well.
That's right, and we should never forget that the governments are supposed to work for us. We are the customers as well as paying for everything. So it'd be really good if we could have access to some of that data in real time as it's going on. Tsunami alerts, earthquake alerts, things of that. We're already starting to get into that realm. Let's broaden that out into other areas as well, and really take advantage of that shared common platform that we're going to see develop.
Colin, I think we're starting to see some of that in the Spark Smart Street down at Wynyard, aren't we?
Yeah.
Which is about running cities.
Yeah, it is. And look, connected infrastructure is probably one of the big value adds, I think, that actually this plays out with. So smart lighting, smart streets, traffic management. If you can think about the big events that we've got coming up, America's Cup and some of the sort of the global industry events that are going to be happening in Auckland in the next couple of years, you can kind of see that ability to do traffic management. If you think about security becoming much more an aspect that we're going to be conscious of, particularly in light of the tragic events down in Christchurch, that demand of actually bringing some of that infrastructure together is going to drive quite a lot of that. And so we're doing quite a lot of work with Auckland Transport and Auckland City Council to understand how do we bring that to life for them to actually be a more efficient city for Auckland. That aspect of connected infrastructure, the infrastructure talking to the cars talking to the traffic lights, that ability to actually have all of that integrated is one of the most powerful things I think you start to see with IoT playing out in 5G.
Yeah, you mentioned the America's Cup, which is a separate thing of its own, but that seems to be a great test bed for you guys.
Well, the thing I love about the America's Cup is it brings all of the three aspects of 5G together in a single integrated event. So if you think about one of the big things that the America's Cup and Emirates Team New Zealand have, they have about 200 sensors on their boat. They used to download that to effectively a hard drive and then dock that at the wharf that night, take the hard drive and then go and do all the analysis that night to see what they needed to do to tweak on that. If we can get connectivity off the boat, which we will, tethered together with some video footage, then they actually have the ability to do real-time adjustments to understand what the cause and effect of those adjustments are going to be. And ultimately everything is for them to make the boat go faster. But then you think about some of the high capacity demands, is it's going to be all raced pretty much in the Auckland Harbour area, on the Hauraki Gulf. There's going to be fan zones in Devonport and Mission Bay and all that. That density of population watching those events on a Saturday or a Sunday is going to create massive bandwidth demands on that, particularly when they're looking at their app for virtual reality or augmented reality experiences which are going to be delivered. And then you think about the crowd control, the traffic management, the rubbish bins, the ability to actually manage all of those big events. Again, you're going to need that connectivity to actually bring that together, not to mention sort of the challenges also wanting some aspect of connectivity around that. So, the Wynyard Quarter and the Smarter Street and the Emirates Team New Zealand based down there, perfect innovation precinct for us to actually be working together around bringing that to life and see how it can work out. And we're super excited about that opportunity.
Paul, you keep an eye on developments overseas. How are we tracking on all this compared to the rest of the world?
Well, we're not too far off the front of the pack, to be honest. South Korea, of course, tends to be the world leader in these things. Samsung is pushing ahead and determined to become a global leader in 5G technology. So it's using the South Korean population as a as a deployment model to test it out and see how they can do. They've rolled out a national network that they say is 5G enabled. The Americans say, oh no, it's not quite 5G. There are issues around that. We've got a 5G network, and parts of America do, but it's very much still a test bed environment. We're not too far off the boil, really. I think in the next year, possibly 2 years, you'll see dozens of countries deploy 5G. We'll get the spectrum auctioned off, we'll get the networks deployed, and we're starting to see a lot of operators gear up ready for it in the next 18 months, 2 years. So we're right up there with the leaders, really.
What's the time frame here, Colin, specifically with regard to IoT and machine-to-machine?
Look, I think, 5G, we've made a public announcement out 1 July 2020 in terms of wanting to be there for Emirates Team New Zealand to start the defence of the America's Cup, but and also the work we're doing around Wynyard. I think in terms of the time frame on machine to machine with 5G, as I said, it's in the next release of the 5G standards, and that's sort of effectively coming to market this year. Then you've got the network technology then has to be married up with the end devices, and so we're really looking at the device ecosystem to bring that together. So realistically, I think there's still a long life in terms of LoRa and 4G. I mean, if you think about when you're deploying an IoT appliance, it's going to be in life for 10 years, 15 years in some instances. It's quite expensive to deploy that going forward. So I think effectively you'll start to see a continued evolution of LoRa and 4G IoT. And then we'll start to actually bring in, I think, probably in the next 12 months, that view about how we can actually bring some of those IoT examples to life in terms of 5G.
I guess that's quite an important thing for people potentially planning to invest to understand, that it's not like if you buy a LoRa or 4G device network now that it's not going to work.
Yeah, and that's and if you think about, we still have a 3G network running, voice calling underneath a 4G network, and some of the other carriers in New Zealand have a 2G network still going. So, it's not necessarily that we're going to roll out 5G and bang, that's the end of anything that we've had before. 5G will be an evolution. It's a natural augmentation for capacity because it has better efficiency, it can carry more data, gives us more spectrum, but it doesn't mean that we then take out the 4G layer on that. And we still think there's a long path to the IoT structure around 4G to go yet.
Well, I'm looking forward to July next year.
Yes, so am I.
Cheers. Thank you very much, gentlemen.
Thank you.
Cheers.
Spark's network lead Colin Brown and telecommunications commentator Paul Brislen. That's all for this episode of the Internet of Awesome Things, brought to you by Spark. Thanks to everyone involved in making this podcast, to Gareth Thomas for the theme music, and to you for joining us. You can subscribe for more of the Internet of Awesome Things at spark.co.nz/IoT podcasts, or wherever you get your podcasts. If you like what you've heard, please rate and subscribe to us. We're also keen to hear your thoughts and questions about what we're doing, and you can get hold of us via iot@spark.co.nz. I'm Russell Brown, and I'm looking forward to catching up then, because you and I, we have 20 billion things to talk about.